Okay, in the last video, we talked about asymptotes and how to find them given a rational function. Now, we are going to go ahead and apply that along with our techniques for finding intercepts and other points, and we're actually going to talk about graphing rational functions by hand. Alright, so let's go ahead and pick up where we left off. We talked about asymptotes. And so remember that we're going to look at problems that have one of two options. The first one that we have is we do have vertical asymptotes. And so remember that to find the vertical asymptotes, we want to set the denominator equal to 0 and solve. The second thing that we have is horizontal asymptotes. And remember that for horizontal asymptotes, we want to look at the leading terms. If the degree of the top is smaller than the degree of the bottom, then we have a horizontal asymptote of y equals 0. If the degrees are the same, then we want to divide the leading terms, and we want to simplify, and we're going to keep whatever that number is. Remember that if you simplify for both and you still have variables running around in the denominator, then you have a horizontal asymptote of y equals 0. We are not going to look at any of the other cases. The only other ones that we might see is if we have wholes, and we'll talk about those when we get to them. Now we are going to add these two new concepts onto things that we already should be finding. When we talk about graphing anything, we want to find intercepts. And so we want to find the y-intercept. The y-intercept, there is nothing new or special about this. Remember that to find the y-intercept, we plug in 0 for x and simplify. We also want to find x-intercepts, and what we want to do is plug in 0 for y and solve. Now, just so you know, this one's going to be a little bit different, and it's mostly just a shortcut. What we're going to do for our x-intercept is we can set the numerator equal to 0 and solve. In order for the rational function to be equal to 0, then that means that the numerator has to be 0. And so we really don't care about the denominator. The last thing that we want is we want to find other points. We should, when we graph, we do want to have our intercepts and our asymptotes. And we do want to have at least one or two other points on each piece of our function. For this, you may go ahead and use a calculator to plug in other numbers, or you can use the table features on your calculator to find at least 2 points on each piece. This can include the intercepts. All right, let's go ahead and try some examples now. All right, so as we go through these examples, I do want to kind of point out the little notes that I'm going to make to myself so that I remember all the different procedures for each one of these. All right, so we want to start by finding our asymptotes and our intercepts. All right, if we start with the vertical asymptote, remember, this is when denominator is equal to 0. And so if we set our denominator equal to 0, we get x minus 1 equals 0, which then turns into x equals 1. All right, the next thing we want is horizontal asymptote. And so our horizontal asymptote, we are going to look at the leading terms. And if we look at the leading terms, we get y equals 3 over x. And because we do still have x running around in the denominator, remember that as x gets really, really big, our fraction is going to get really, really, really small and head towards 0. And so our horizontal asymptote is going to be y equals 0. All right, that is that one. Okay, so now we want intercepts. All right, we are going to start with y-intercept. And for this, we want to let x equal 0. Remember, intercepts, we always plug in 0 for the other thing. And so if we plug in 0 for x, we get 3 over 0 minus 1. And if we simplify this, we get negative 3. We do want our y-intercept in point form. And so this is going to be when x is 0, y is negative 3. All right, and finally we have x-intercepts. Equal to 0. And, well, if we set the numerator equal to 0, what we get is 0 equals 3. And that is not a true statement. We cannot solve it. And so what this means is we have no x-intercepts. All right, we're going to go ahead and start with this for our framework. We're not done. We do still need at least 2 points on each piece, and right now I've just got 1 point. But before I start doing anything else, I'm going to go ahead and graph what we have so far. All right, so we have a vertical asymptote at x equals 1. And remember that when we label this, when we find this, we do need to make sure that it is an equation. The second thing that we have is we have a horizontal asymptote at y equals 0. And same thing, it does need to be as an equation. And then we do want to go ahead and plot the 1 point that we have right now, which is 0, negative 3. Okay, from here, we do need 2 points on each piece. Okay, and basically what we're going to do is we're going to use our x equals 1 as kind of our boundary line in terms of our left and right side. All right, so we can plug in any numbers that we want, but I am going to try to pick numbers that will give us nice answers. This is one of the reasons that I recommend using the table features on your calculator, or just using a calculator in general. All right, so what I'm going to do is I'm going to plug in x equals negative 2. Now, if we plug in negative 2, what we get is 3 over negative 2 minus 1. You do not have to show these steps. As I said, I want you just to find the points, use your calculator, but we should get negative 1. And so that is going to be another point that we can plot on here. We have negative 2, negative 1. And that takes care of the 2 points that I need on this piece of my graph. Now, when we graph this is going to be some of the things that I'm going to be looking for. In terms of the asymptotes, remember, these are lines that we want to get closer and closer to, but we do not want to touch them, and we do not want to veer away from them. So, for instance, here, I'm going to start close to my x-axis. I'm going to go through my points, and I'm going to get close to my vertical asymptote. All right, now I don't have any points on my second piece, and so we need to go ahead and find some of those. So let's see here. I'm going to go with x equals 2. And if we plug in x equals 2 to our function, we get 3 over 2 minus 1. This is equal to 3 over 1, which is equal to 3. And so we have a point 2, 3 on our graph. All right, that's 1 point. Now we do need one other point, and I'm going to plug in x equals 4. And if we plug in 4, we get 3 over 4 minus 1. This is 3 over 3, which is equal to 1. And so we have another point at 4, 1. These are not the only points that you can find, but these are probably going to be the nicest points that you can find. All right, so same thing. We want to approach our asymptotes. We don't want to cross them. We don't want to veer away from them. We don't want to touch them. And so we should get that our final answer should look like this. All right, let's go ahead and try the next one. All right, example B. We have 4x plus 1 over x squared minus 4. And so we are going to, again, start with our asymptotes. All right, vertical asymptotes. We want denominator equal to 0. And so if we do x squared minus 4 equals 0, we can either factor or we can do square root property, and we get x equals plus or minus 2. Again, remember, because these are asymptotes, we need to separate them. So we want x equals 2 and x equals negative 2. All right, we want our horizontal asymptote. And our horizontal asymptote, we want to look at the leading terms. So if we look at our leading terms, we get 4x over x squared. I can cancel 1x, which leaves me with 4 over x. But again, this is not a number, and so because we still have x's running around in our denominator, remember what this means is as x gets really, really, really big, our fraction's going to get really, really, really small. And so we have a horizontal asymptote of y equals 0. All right, we want our intercepts. And so for our y-intercept, we let x equals 0. And if we plug in 0 for x, what we get is 4 times 0 plus 1 over 0 squared minus 4. Any term that contains a 0 in it cancels or goes away, and what we're left with is negative 1/4. So our y-intercept, when x is 0, y is negative 1/4. And then finally, x-intercepts. We want to set y equal to 0, but that is the same thing as the numerator equal to 0. And so if we set our numerator equal to 0 and solve, we get 4x equals negative 1 and x equals negative 1/4. Now note that even though it looks like our y-intercept and our x-intercept are, the same, keep in mind there is no relationship between the y-intercepts and the x-intercepts in general. Okay, just so happened that that's how this worked out. All right, so our x-intercept is negative 1/4, comma, 0. All right, let's go ahead and start graphing this. All right, we have our asymptotes. On this one, we have two vertical asymptotes. We have a vertical asymptote at x equals 2. And we have a vertical asymptote at x equals negative 2. All right, we have a horizontal asymptote of y equals 0. And so we'll go ahead and put that in there as well. All right, we have our intercepts. We have a y-intercept of 0, negative 1/4, which is going to be somewhere right around there. And we have an x-intercept of negative 1/4, comma, 0. And that's going to be somewhere right around there. All right, now, we do want to find other points on our graph. Okay, so let's see what we can do here. And they may not necessarily be nice points, but we're going to try to find the nicest ones that we can. All right, let's see here. All right, I'm going to go ahead and use the table features on my calculator. And so this is what I'm plugging in. For y1, we do want to make sure that we have parentheses around everything. So I am going to do 4x plus 1, my numerator inside parentheses. And then I'm going to put my denominator in parentheses, which is x squared minus 4. Okay, for my middle piece, I have my 2 points. We don't need any more, but if you want, you can do another one. But what we need to do is we need to come over to the left piece. Let's start with that one. We want to pick numbers that are less than negative 2. And when I do this, to me, negative 4 gives me a fairly nice point. It's negative 1.25. And when I plug in negative 3, I also get a fairly nice point. It's negative 2.2. Okay, I don't mind if you use decimals. All right, so let's go ahead and plot these. We get negative 4, negative 1.25. So negative 4, negative 1.25, which is going to be somewhere around here. And we have negative 3, negative 2.2, which is going to be somewhere around here. And we want our graph again to approach, not cross, not touch, and not veer away from our asymptotes. And we're going to label. All right, I'm going to put in a couple more points for my middle, just to kind of make it a little bit nicer. If we plug in negative 1, we get 1. And I think that's the only one I'm going to do. If we plug in positive 1, I get negative 1.666666667, and I really don't feel like graphing that. But what we should see is that this here, and that's not very good. Maybe I should have done that. This middle piece looks something like this. All right, if we go over to the right side, When x is 3, I get y is 2.6. I'm going to skip 4 because it was not a nice number. And when I plug in 5, I get y equals 1. And so we'll go ahead and plot those. So 3, 2.6, 5, 1. And then we have our graph. Again, we want to approach, but not cross, touch, or veer away from our asymptotes. We label. We had -1, 1. And my asymptotes, I'm just going to label them A and B, just to make it a little bit easier. And we have our graph. All right, so both of these examples are examples that have a horizontal asymptote of y equals 0. And so as we can see, there's lots of different things that we can do. Be very careful when you start trying to find patterns on your own. Make sure that you do enough examples before you start making assumptions. All right, let's go ahead and look at our next set of examples. All right, let's go ahead and look at the next set of examples. All right, for example C, again, we're going to start with our asymptotes and our intercepts. All right, so if we start with our asymptotes, vertical asymptote, we want the denominator equal 0. If we set the denominator equal to 0, we get a vertical asymptote of x equals 3. For our horizontal asymptote, we want to look at our leading terms. And if we do this, we get y equals x over x, and that does simplify, and so we do get y equals 1. All right, for intercepts, if we plug in 0 for x, we get f of 0 equals 0 plus 3 over 0 minus 3. And if you simplify this, we get -1. We want this in point form, so this is going to be 0, -1. And for our x-intercepts, we want to set y equal to 0, or the numerator equal to 0. And if we do that, we get x plus 3 equals 0, and we get x equals -3. And so when x is -3, y is 0. All right, let's go ahead and start graphing this. We're going to start with our vertical intercept, or vertical asymptote. We have a vertical asymptote at x equals 3. We want to draw a dashed line. We want to label it with the equation. All right, we have a horizontal asymptote of y equals 1. So this is going to go side to side, and we label y equals 1. All right, we want to go ahead and label our points. We have a point at -3, 0. We have another one at 0, -1. And then we want to go ahead and find a few more. All right, if we go ahead and plug this into our calculator, we're going to go y1 equals x plus 3 divided by x minus 3. And we want to pick some points. We have lots of good points here, and I do recommend putting in at least one more on the left side. And I'm going to go with x equals 2, and when x equals 2, y equals negative 5. This basically just gives us the more points we have, the better shape we have. But we do have our minimum of 2 points on the left side. Now we do need 2 points on the other piece. And so for this one, I see that when x equals 4, we get y equals 7. I have when x is 5, y equals 4. And when x is 6, y equals 3. So there are lots of good points to choose on this one. All right, so let's see here. I'm going to go 4, 7. That's going to be up here. We have 5, 4, and 6, 3. And my graph is not fantastic, so I'm just going to go ahead and extend my asymptote just a little bit, because remember that we do want to make sure that we are approaching our asymptote. All right, so when we graph this, on the left side, we should get something that looks like this. It's not fantastic, but it'll have to work. And then on the right side, we get something that looks like this. We do want to label, and so we had a x-intercept of negative 3, 0. We had a y-intercept of 0, negative 1. I found another point on this which was to negative 5. We had a point of 4, 7. Another point of 5, 4. And another point of 6, 3. All right, let's go ahead and look at the next one. All right, for example D, we have f of x equals 6 minus 2x over x plus 3. All right, we are going to start with our vertical asymptote. We want to set the denominator equal to 0. And if we do this, we get x plus 3 equals 0 or x equals negative 3. All right, for our horizontal asymptote, we want to look at our leading terms. And remember that leading terms are the terms of highest degree, not necessarily the ones in the front. And so here, when we look at our leading terms, what we actually want to divide is negative 2x and x. This does simplify. We can cancel out our x's, and we are left with y equals negative 2. All right, we have our y-intercept. We're going to set x equal to 0. And so if we plug this in, we get 6 minus 2 times 0 over 0 plus 3. Anything that has a 0 in it's going to cancel. And if we simplify this, we get 2. And so what we have here is for our y-intercept, when x is 0, y is 2. And finally, for our x-intercept, we want to set the numerator equal to 0. If we set the numerator equal to 0, we can solve for x. We get negative 2x equals negative 6. We subtract 6 from both sides. And if we divide by negative 2, we get x equals 3. We want this in point form, and so this is going to be when x is 3, y is 0. All right, let's go ahead and start graphing this. All right, we had a vertical asymptote at negative 3, negative 3. So we're going to draw a vertical line, an up and down line at negative 3. We have a horizontal asymptote at negative 2. And so we're going to draw a line side to side at negative 2. And then we want to go ahead and plot our intercepts. So we have a y-intercept at 0, 2. We have an x-intercept at 3, 0. And I'm going to go ahead and find a couple more points on here using my table. All right, if we look at numbers that are less than negative 3, they start to get kind of big, but I see that we have negative 7, negative 5, negative 6, negative 6. I'm going to go with negative 5, negative 8. Okay, so these are not fantastic, but this is the best that we're going to get. And so if we go negative 7, negative 5, we're going to be right here. Negative 6, negative 6. Negative 5, negative 8 is going to be even further away. And we need to do our best to approach our asymptotes, but as you can see, it's going to be a while before we get close to those asymptotes. I'm going to add in a couple more points on my other side. We have negative 1, 4. And I do have 5, negative 0.5. Okay, it's not fantastic, but, you know, gives us a little bit more shape to go with. And so when we draw our graph, remember that we do want to approach our asymptotes. We don't want to cross, we don't want to touch, and we should get something that looks like this. All right, that takes care of those two. Now these two are examples of graphs that have one vertical asymptote, and it also has a horizontal asymptote, but these ones, we had horizontal asymptotes that were not 0. All right, let's go ahead and look at a couple more examples and see what else these things are going to look like. All right, we're going to go ahead and look at a couple more examples and see what happens with these. For these ones, we're going to have multiple vertical asymptotes, and we're going to see kind of some of the more of the variety that we can have with rational functions. All right, so let's go ahead and get started and see what we can do here. We are going to start with our asymptotes. All right, vertical asymptotes. We want our denominator equal to 0. And if we set our denominator equal to 0, we're going to get, we can either factor or do square root property. And we should get x equals plus or minus 2. Again, remember, because they are not numbers, they are equations of lines, we do want to separate this. So we want x equals 2 and x equals negative 2. All right, for our horizontal asymptote, we want to look at the leading terms. And if we do this, we get 3x squared over x squared. And we can go ahead and simplify. If we simplify this, we get y equals 3. Okay. All right, we want our y-intercept. And if we let x equal 0, we get f of 0 equals 3 times 0 squared plus 1 over 0 squared minus 4. And any terms with zeros are going to cancel. And so we get negative 1/4. We want this as a point, so this is going to be when x is 0, y is negative 1/4. All right, and the last thing that we want is x-intercepts. So this is where our numerator is equal to 0. But if we set our numerator equal to 0, well, we get 3x squared equals negative 1. But we can't do this. We can't have 3 times a positive number equaling a negative number. And so for this, we have no x-intercepts. All right, so let's go ahead and graph what we have so far. All right, we have our vertical asymptotes. We have a vertical asymptote at negative 2 and positive 2. All right, we have a horizontal asymptote at y equals 3. And then we want to start plotting our points. So we have a y-intercept at 0, negative 1/4. And then we want to go ahead and use our table in order to find some other points. So let's start with numbers less than negative 2. Unfortunately, we don't have any super nice points, so we're just going to try to pick the nicest points possible. I'm going to go with negative 4 and 4.1. Now, note this is an approximate value. I did have to round this. And I'm going to go with negative 3 and 5.6. All right, if we plot those, we have negative 4 and 4.1. It's going to be right there. We have negative 3 and 5.6. It's going to be somewhere up here. And then we're going to go ahead and draw our graph through these points. Now, when you're working on your homework, I do want to kind of point out one thing real fast here, is in the homework, it is not going to allow you to put in decimal approximations. And so we're going to go back and actually compute this after we get our graph done. All right, for our middle one, we have 1 point already. And so I'm just going to go ahead and find a couple more, at least one more. And I'm going to go with when x is negative 1, we get negative 1.33. And again, this is an approximation. And same thing when we plug in 1, we get negative 1.33. This is also an approximation. All right, if we go ahead and plot these, we have negative 1 and negative 1.33. And same thing on the other side. And so what we get for this piece is this is going to be something like this. All right, and then we want some points on the other side. And so on the other side, we have 3 and 5.6. And we have 4 and 4.1 again. And so when we plot these, we have positive 3 and 5.6. We have 4 and 4.1. And so one thing that I do want to point out is notice here, when we change the sign of our x's, we get this back the same y values. We get 4.1 and 4.1. We get 5.6 and 5.6. We get negative 1.3 and negative 1.3. This function, even though it's not a polynomial, it is even, and it is symmetric about the y-axis. All right, just to kind of talk about some of the stuff that we've talked about previously. Okay, so now, remember this was approximate as well. Okay, for the homework, as I said, for paper assignments, I don't mind if you do decimal approximations. But for the homework, they are going to want exact answers. And so let's go back and look at 2 of these. We only need to do 2 of them because it is even. And figure out what's the actual value. All right, so if we come back over to our function, I'm going to plug in positive 1 and positive 4. Now the first one, if you recognize it, negative 1.333, that should be negative 1 1/3, but we're going to go ahead and solve this anyway. All right, if we plug in 1, we get f of 1 is equal to 3 times 1 squared plus 1 over 1 squared minus 4. This gives us 3 plus 1 over 1 minus 4, which is 4 over negative 3, and I'm just going to move my negative to the numerator or the front. You do not have to write as a mixed number, and so this is the answer that we would want to plug into the homework problem. All right, now the other one that we saw was f of 4, and I don't even know what this is actually equal to as a fraction, so we're going to go ahead and find out. So if we plug this in we get 3 times 4 squared minus 1 over 4 squared minus 4. If we square 4, we just need to simplify numerator and denominator. And again, you can use your calculator for this. If we square 4, we get 16 times 3 is 48 minus 1. And we get on the bottom 16 squared minus 4. Now if we simplify this, we get 47 over 12. This does not simplify any further. If we could divide by a common factor, we should. But we can't, and so we're going to leave it just like that. Okay, so remember, these are my math lab answers. Okay. For paper assignments, I'm okay if you do decimal approximations. All right, let's go ahead and look at the next one. All right, the next one, we have f of x equals 2x squared over x squared minus 9. Okay, we're going to go ahead and start with vertical asymptotes. And if we set our denominator equal to 0, we get x squared minus 9 equals 0. We get x squared equals 9. And when we take the square root, we get plus or minus 3. And again, because these are equations, not numbers, we do want to separate them. All right, for our horizontal asymptote, we want to look at our leading terms. And if we look at our leading terms, we get negative 2x squared over x squared. And my x's cancel, leaving me with just y equals negative 2. All right, we want our y-intercept. We're going to let x be 0. And if we plug in 0 for x, we are going to get negative 2 times 0 squared over 0 squared minus 9. And the numerator, 0 squared is 0. You multiply it by negative 2, you still get 0. The bottom is going to be negative 9, and so this whole thing is equal to 0. And so our y-intercept is 0, 0. And it is also the x-intercept. If we set the numerator equal to 0 and solve for x, well, we get 0 again. All right, let's go ahead and start looking at the graph of this one. Okay, we're going to start with our asymptotes. We have vertical asymptotes at 3 and negative 3. We had a horizontal asymptote at y equals negative 2. And we had a x-intercept and a y-intercept at 0. All right, so now let's go ahead and find some other points. All right, I'm going to start in my middle. And in my middle, I see that we have some other nice points, relatively nice points. At -2, 1.6. I also see one at 2, 1.6. This is also an example of an even function. And so we can go ahead and take advantage of that. So at -2, we get 1.6. That's going to be right about here. +2, we have 1.6. -1, you have 0.25. And at +1, you have 0.25. So 1/4, those aren't too bad either. And so what we have here is we have something that looks roughly like this. All right, so then let's go ahead and look at the other sides and see what we can do. Okay, unfortunately, we don't have a lot of really great points to choose from. And so I'm going to go with 5 and -3.125. And let's go with 6, -2.67. Okay, those seem to be about the nicest points that we can find there. 4 is not a nice one because it's -4.5714, and if I highlight it, it keeps going on forever. And so I picked these 2 points, even though -2.6666 goes on forever. It's a lot nicer because it does have that very easily recognizable pattern. And then the -3.125, I picked that one because it does end. It actually does end at 1.125. There is also 9, -2.25. I'm not picking that one just because that's pretty far away from my origin. Okay, but depending on if you are using graph paper or the graphs that I provide, you may want to pick with that one as well. All right, if we go ahead and graph these now, we have 5, -3.125. And so we're going to be about right here. Okay, it's still pretty close to 3. And we have 6, -2.67. And I graphed that first one wrong. I need to move it over. Okay, that's a little better. 6, -2.67. It's going to be right about there. And because this is an even function, if you go back and look at the other ones, we're going to see the same thing for -5 is -3.125. And -6, we're also going to see that -2.67. And so if we go ahead and plot those, we're going to be over here and here. And we can go ahead and draw. All right. I'm not going to go ahead and label these, but you should. Okay. Again, you can either label them with the points or you can label them with letters. We can go A, B, C. D, E, and keep in mind, it does not matter how you label these, as long as you identify what goes with what. Okay. All right, let's keep going. We're not done yet. We still have several other examples that we can look at. All right, the next 2 examples that we're going to look at are going to be special cases. The first thing that I want to point out is if we look at G, and I'm just going to look at my leading terms real fast. If we try to divide the leading terms, we are not going to get a horizontal asymptote. And even though there is another option that we're not going to look at in this class, the important thing is we're not looking at it in this class. So the first thing that I want to do is I want to go ahead and factor the top and the bottom. And there's nothing wrong with doing that on all of them if possible. Just because, at some point we're going to have to do it. But if we go ahead and factor the numerator, what we get is x minus 2, x plus 2 over x minus 2. We do still have a domain restriction, but here it's not going to be a vertical asymptote. What we're going to have is we're going to have a hole because we do have a factor that cancels. And our hole is going to be when x minus 2 equals 0. We're going to have a hole at x equals 2. All right, from here, if we cancel these, what we see is this is actually equal to the equation x plus 2, simplified. All right, we do still have, we don't have any horizontal asymptotes because, well, this is a linear equation. And so we don't have to worry about that. And we just need to go ahead and graph the line y equals x plus 2. But we do need to remember there is a hole. So if we graph the line x plus 2, this has a y-intercept of 2 and a slope of 1. And so if we draw our up 1, right 1, and here's the thing, when we get to x equals 2, we want an open circle. And we continue on. And so what my graph is going to look like is something like this. We have a hole at 2, 4. How do we get that? You can either look at it on the graph or you can plug 2 into the simplified equation. We get 2 plus 2 is 4. And just a reminder, we cannot equal this. This is a ghost point. We should go ahead and label the other points. And for this one, I'm not going to worry so much about labeling points on each piece because even though it is 2 pieces, it's pretty obvious what we've got here. We should still label our intercepts. We have a y-intercept of 0, 2, and we do have an x-intercept of -2, 0. So this is one of the things that we can see when we have a hole, but this is not the only possibility. All right, let's go ahead and look at another one that has a hole. All right, let's come down to example H. This one we got a lot of stuff going on here, and so again the first thing that I want to do is I want to go ahead and factor both top and bottom and see if we have anything that cancels. And so if we factor the top and bottom, what we're going to get is x minus 2, x plus 1 over x minus 3, x plus 1. Before we simplify, we do have a hole when x equals -1. That is this factor right here. That does cancel out. But we also have a vertical asymptote. We do still have a factor in the denominator, that does not cancel. And so it is still going to be a vertical asymptote. We are only going to worry about the x minus 3 equals 0. And so we have a horizontal asymptote at x equals 3. All right, so those two factors cancel. And so now let's go ahead and figure out what the whole is. And so we're going to plug -1 into the simplified fraction. If we plug -1 into the simplified fraction, we get -1 minus 2 over -1 minus 3, and we get -3 over 4. And so our whole is going to be -1, comma, positive 3/4. We should have that our negatives cancel. Okay. That takes care of our domain and our restrictions on the x, the two things that can happen. We do have a horizontal asymptote for this. So if we only look at the simplified function, remember we're going to look at our leading terms. And what we get is y equals x over x, which is equal to 1. So we have a horizontal asymptote at y equals 1. All right, y-intercept. If we plug in 0 for x, what we get is f of 0 equals 0 minus 2 over 0 minus 3, which is 2/3. And finally, for our starting points, we want our x-intercept. Our x-intercept, we're going to set the numerator equal to 0. And we get x equals 2. All right, we're going to go ahead and start with this information. Okay, we are going to start with our vertical asymptote. We have a vertical asymptote at 3. X equals 3. We have a horizontal asymptote at y equals 1. So this is going to be going side to side. And I'm also going to put in my whole. And so we have a whole at -1 3/4. Okay. Our intercepts, we have an intercept at 2, 0. And we have another intercept at 0, 2/3. And that's going to take care of basically this piece right here. All right, let's find some points on the other piece. All right, so if we go to our table, and for this, you can plug in the original function or the simplified function. I'm going to do the simplified function, means typing less buttons. And what I see here is when x is 4, I get a y of 2. And if I plug in 5, I get a y of 1.5. So we can go ahead and plot those. We have 4, 2, 5, 1.5. And again, we want to approach our asymptotes but not cross them. And we should get something that looks like this. All right, so those are two examples of equations that have holes in them. Okay. We have one more example left that we're going to look at. And so let's go ahead and look at that one now. All right, the last one that we have is going to be 3 divided by x squared minus 9. All right, so let's go ahead and see what this looks like. The numerator does not factor. We don't have any holes on this one. And so what we're going to do is we're going to go ahead and start with our asymptotes again. Vertical asymptotes, we want our denominator equal to 0. If we do this, we get x squared minus 9 equals 0. We can do square root property, get x squared equals 9, and we get x equals plus or minus 3. Remember that because these are equations, we are going to separate them. We also want our horizontal asymptote. And remember, horizontal asymptote is the leading terms. And so if we look at this, we get y equals 3 over x squared. And well, we can't do any kind of cancellations, and we still have variables running around in our denominator. And remember what this means is as x gets really, really, really big, we are going to be approaching 0. And so that is our horizontal asymptote. All right, y-intercept. If we plug in 0 for x, we get 3 over 0 minus 9. And if we simplify this, we should get negative 1 over 3. We want to simplify our fraction. And so our y-intercept is 0, negative 1/3. X-intercepts, we want our numerator equal to 0, but our numerator is just 3, and so there are no x-intercepts. All right, so let's go ahead and start graphing this. All right, we're going to start with our asymptotes. We have a vertical asymptote at negative 3. X equals negative 3. We have another one at x equals positive 3. All right, we have a horizontal asymptote at y equals 0. And we have a y-intercept at 0, negative 1/3. All right, so let's go ahead and find some other points on this. All right, when I look at my table, I'm going to try to pick the nicest ones here. When x is negative 2, we have y is negative 0.6. I also have that for positive 2. I also have negative 0.6. And so when we graph those, we should be about right here on both of them. And so our graph is going to look something like this in our middle piece. Again, we had the 0, negative 1/3, which I'm calling A. And I'm going to let these ones be B and C. All right. Let's go ahead and see what other points we can find. And they're not very promising. So I'm going to go with negative 6. And we have 0.11. And if you want, you can approximate that. But we have negative 6, 0.11. And I think the next nicest number I have is negative 6.11. And the next nicest I have is negative 5.19. And again, this is an approximate. So if we graph that, negative 5.19, that's not really all that much higher. This one actually is very, very shallow right here. And it's not until it passes the 0.4 or the negative 4 that it really starts taking off. It is an even function, and so we are going to see that it's going to look the same on the other side as well. All right, I'm going to call this D and E. And we'll go F and G. All right, that's our last example that we're going to look at. Now, keep in mind that these are just some examples of what rational functions can do. If you go into the pre-calculus and trigonometry class, which is the next one in this sequence, we will add another category of rational functions to our repertoire. But for right now, we are only going to focus on the ones that have horizontal asymptotes and possibly holds. Okay, that finishes this section. For this, again, when you're doing these, I do recommend writing down these hints as much as possible in terms of how do we find the vertical asymptote, how do we find the horizontal, the intercepts. Write down your hints as much as possible so that you can really internalize all of these different procedures. Each one is simple, but it's when we combine them all together that we start getting lost. All right, that finishes this one, and so I will see you for the next one. Thank you.